Okay, so now we're going to evaluate b of 2x minus 1, and we're going to replace the m in this b to the m with 2x minus 1. So we're going to use this function, and everywhere there's an m, we're going to replace it with 2x minus 1. And simplify. Now we're going to evaluate the other one, the 3b of x, and so everywhere there's an m, we're going to replace it m with x. Now we are to subtract them from each other. So what we got the first time, and we're going to subtract from it what we got the second time. We're going to combine our like terms. We end up with 2x squared minus 9x plus 3. So it's quite a few steps. You may need to go back and look at that one again, but follow it step by step logically. Now if you're writing all over your paper, you're going to pretty much get lost. So try to keep it even, work down your paper as you're solving the problem. And it's time for you to check one on your own. So pause, work the problem, then come back and check your answer. Okay, when I found g of 2x plus 1, I ended up with 4x squared plus 4x plus 4. And then when I found 2g of x, I ended up with 2x squared plus 6. So when I took 4x squared plus 4x plus 4 minus 2x squared minus 6, I ended up with 2x squared plus 4x minus 2. The general shapes of the graphs of several polynomial functions show the maximum number of times the graph of each function may intersect the x-axis. This is the same number as the degree of the polynomial. So a degree of 1, it crosses the x 1 time. Degree of 2, 2 times. Degree of 3, 3 times. 4, this was what's called a quartic function. Degree of 4. A quintic function is degree of 5. Notice it crosses the x 5 times. The domain of any polynomial function is all real numbers. The end behavior is the behavior of the graph of f of x as x approaches positive infinity or negative infinity. The degree and leading coefficient of a polynomial function determine the end behavior of the graph and the range of the function. So let's look at the end behavior. Notice that the function's x squared, as the function approaches, it approaches positive infinity as x approaches positive infinity, and it approaches positive infinity as x approaches negative infinity. This one's an even because notice the ends, they're both going in the same direction, and it's pointing up. The leading coefficient's positive. Okay, this one has an odd degree. So we've got x cubed. It's a cubic function. Notice that as the function approaches negative infinity, x is also going toward negative infinity. As the function goes towards positive infinity, x goes towards positive infinity. The degree is even. So notice the ends are going in the same direction. That's how you know it's even. Odd, they're going in a different direction. On this one, the function's approaching negative infinity as x approaches negative infinity. The function approaches negative infinity as x approaches positive infinity. So we read this, the f of x approaches negative infinity. Okay, here's another odd one. It's got a negative slope. It ends up going downhill. This one's positive, got a positive leading coefficient, it ends up going uphill. Okay, so we'll read this one. The function approaches positive infinity as x approaches negative infinity. The function approaches negative infinity as x approaches positive infinity. So when you're asked to describe end behavior, that's what we're looking for. What's happening to the function as x approaches positive and negative infinity? Now the number of real zeros of a polynomial function can be determined by examining its graph. Recall that real zeros occur at x-intercepts. So this one has no zeros. It doesn't cross at all. This one has 1, 2, 3, 4 zeros because it crosses 4 times. This one has 3 zeros, 1, 2, 3. This one only has 1 zero, crosses the x, intercepts the x 1 time. Odd degree functions will always have an odd number of real zeros. So this one can either have 3 or 1. Now even functions will have an even number of real zeros or no zeros at all. So like this one could have 4, it could have 2, or 0. So just remember all the even numbers in 0 and only odd numbers. And the highest will be whatever the degree of the polynomial is. So that'll help tell you how many zeros you're looking for. Okay, so let's look at the graph of this polynomial. First of all, we're to describe the end behavior. So what's happening to the function? It's approaching negative infinity as x approaches negative infinity. And it also approaches, it goes to negative infinity. It's going down as x approaches positive infinity. It's an even degree polynomial. Notice the ends are going in the same direction. That means it's even. And the graph does not intersect the x-axis, so the function has no real zeros. Okay, let's look at another one. End behavior. As x approaches positive infinity, the function also approaches positive infinity. What happens as x approaches negative infinity? Yeah, good. The function is also approaching negative infinity as x approaches negative infinity. The ends are going in opposite directions. It is an odd degree polynomial. The graph intersects the x-axis at 1 point, so the function has only 1 real zero. Okay, time for you to check your progress. So pause for a moment and describe this graph of this polynomial. We know it's an even degree because ends are going in the same direction. Very good. And it intersects the x in 2 places, so it has 2 real zeros. Let's try another one. So pause for a moment, study this graph, and then tell me which answer did you select. It is odd. The ends are going different directions, and it has 1, 2, 3 real zeros. Very good. Okay, you're ready to practice on the assignment. Good job.